Now we have discussed about the binary addition process, and there is an interesting point. I don't know whether you have noticed or not. That is, we always start from the right hand side, right, and to the left hand side. So, uh, if I go back to binary to decimal conversion, how we do, we write one, say for example this one 1101. I have written 13. How, why I have written? Because 1101, if I have this decimal number and if I want to convert them to binary, what we write? We write their index starting from 0, from the left right hand side, from the, I'm sorry, do one thing. Let's write 110 only, not 1101. 110. Okay. So here now the index of 0 will be 0, index of 1 is 1, and index of 1 is, this one is 2. So this is the index, and then what we write? We write 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0, right, equal to 2 to the power 2 means 4 plus this is 2 plus this is 0, right, that means equal to 6, right. Now you see there is a very important uh, things over here in this. If I want to change this number in a two different way, for example, I had number 110, right, the number I had 110, and if I add an extra bit in the right hand side, say for example I put a 1, and then if I calculate the total number of I mean if I calculate the corresponding decimal value, okay, if I calculate the decimal value, uh, just a minute. No, just I want to let's try to realize from a different way. Suppose that I have a number, say for example, uh, 1101. Okay, suppose I have a number 1101. Yes, 1101. So just after this 110, I have written a 1, something like this. Then if you find what will be the result, it's obviously 0, 1, 2, 3. That means 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. So if you just calculate this, you will find it is basically 13, right? It is basically 13, right? Now see, instead of 1101, if I keep the part, this part remains same, 110, and I change this part to 0, just this part I have changed, what will be the corresponding value? it will be 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus basically 0, right? Because anything multiplied with zeros will be remain 0. So what will be the value? The value will be 12. So just observe this, that instead of in the rightmost side, if I toggle a particular bit from 1 to 0 or maybe from 0 to 1, it is not changing the value of the number a lot. I have 13, I got just 12. There is only one difference. But if I do the same thing, like if I now change this particular bit, how I will change? I will keep the, I mean actually I should say that the arrow should be something like this. The arrow should be something like, I have this three part you consider remain same. So 101 remains same, and this bit I have converted to 0. Okay, this is another situation. In the previous case I toggled the rightmost bit, and in this case I have toggled the leftmost bit. Other bits remain same. Now what is the result of this? This is 0 plus obviously 0, 0 into something, then this one, that means 1 into 2 to the power 2 plus again 0 because of this 0, and then plus 1 into 2 to the power 0. What will be the result? Result will be equal to 5. Now try to observe this one, that when I am changing a leftmost bit from 0 to 1 or maybe from 1 to 0, the value, the corresponding decimal value that we have a huge change. It was 13 in this 1101, but instead of 1 if I write 0, the value become 5. So difference. But just in opposite way, if I change the rightmost bit and other bit remains same, it's 12. So difference is not much. That means in as an observation, what we can say? As an observation, what we can say? We can say that the change in the leftmost bit has greater impact than changing in the rightmost bit. That means I can say, significance of the leftmost bit is highest, and significance of rightmost bit is lowest. As simple as that. From this point actually it came. That's why this is the reason, if we have a number having say A, B, C, D is a number. I mean A is some 0, 1, or maybe B is also either 0 or 1 or C. It's a binary number, assume. Okay. This one, that is the leftmost bit, is called least, I'm sorry, I'm sorry, uh, most significant bit, and rightmost is called least significant bit. In short we say MSB, and in short we say LSB. Always remember this one. This is true for any situation. It's not for decimal value. Even it is true for a binary number system. Sorry, it's not for a binary number system. It's for any number system.